Chapter 2, Video 6. Alright, so today we're going to talk about the different intervals in the QRS complexes, and I'm going to give you some information on that. I'm not going to flip through the slides. I want you to, I want to leave it on here. I'm teaching from your PowerPoint, so make sure that you review all of your PowerPoints and you are up to stuff on everything that I'm going over. But however, I'm not going to flip back and forth. I'm going to leave this like it is so we can so you can look at it while I'm talking. The first thing that we're going to talk about is our intervals. The intervals is the measurement of time between the P, the QRS, and the T waves and complexes. Measurements allow determination of the heart's efficiency at conducting impulses down the pathway. So remember when we looked at the graph paper, and I told you that it represented time and what the small blocks versus the big blocks versus 5 big blocks equaled. This is where this comes into play, and this is where you will use those blocks to measure time. So first we're going to talk about the PR interval. Remember, this is the P wave, P, and then we got the PR, the QRS, so we got the QRS complex, and then we have the ST segment, and then we have the QT interval, and so on. So I will show you as we talk about each one. First, we're going to talk about the PR interval. It starts with the P wave, and it ends with the R wave. And remember, we said the R is anything above, that goes positive above that isoelectric line. So right here where this starts going upward ends the PR. So it starts with the P, and it ends with the R. So this is the PR segment. The PR interval measures the time for the impulse to get from the atria to the ventricles, okay? So this is what we're looking at. When we're looking at the P wave, we're looking at that impulse traveling across that atria, and when it ends at the R, this means it's reached the ventricle. So the time that it takes for the impulse to get from the atria to the ventricle is the PR interval. The normal PR interval, and you need to remember these numbers, these are very important, you will see them again. The normal PR interval is 0.12 to 0.20 seconds, and that's on your printout. I need you to highlight that and remember. So anywhere from 0.12 seconds to 0.20 seconds, that is a normal length of time for this segment, for that PR segment. So we would measure from the P wave to the R wave to get that. It's measured from the beginning of the P wave and the beginning of the QRS. It includes the P wave and the PR segment. So this PR interval, this is the PR interval right here. Alright, the P wave itself should measure no more than 0.10 seconds wide and 2.5 millimeters in height. Now let me say this, back to that graph paper. When we measure from left to right, we are measuring time. If we measure up and down, we are measuring the height of it. We're measuring the amplitude of it. Alright, now we're going to talk about the QRS interval. And as you can see here, this is the QRS complex. And it measures the time, this section right here. All of this is the QRS complex. It measures the time to depolarize the ventricles. Okay, so how long does it take for those ventricles to be depolarized? A normal QRS interval is less than 0.12 seconds, usually between 0.06 and 0.10 seconds. It's measured from the beginning of the QRS to its end. Okay, so this is the section we're talking about with that. Now we're going to talk about the QT interval. The QT interval, it starts at the Q and ends at the T. The QT interval measures depolarization and repolarization time of the ventricles. So how long does it take the ventricles to depolarize and repolarize? So the depolarization happens, and how long does it take them to get through the repolarization process? That is measured from the QT. Guys, this is important to know what you're looking at and how long it takes. Not only do you want to know how long it takes, but you want to know exactly what you're looking at and what's happening, what's supposed to happen, what is the function with that heart. what is happening in that segment. What function am I looking at? So the measurement of the QT interval, it's measured from the beginning of the QRS to the end of the T wave. It does include the QRS complex and T wave, and it should be less than or equal to half of the distance between the successive QRS complexes at heart rates between 60 to a Herman. It should be less than or equal to 1/2 of the distance between successive QRS complexes at heart rates between 60 and 100. That sounds more like it. I apologize, I was getting tongue-tied. To determine if the QT is prolonged, draw a line midway between the QRS complexes. If T wave ends at or on or before this line, the QT is normal. If it ends after the line, it is lethal and can lead to an arrhythmia. Okay? If you have questions about that, let me know. But again, to determine if the QT is prolonged, we're going to draw a line midway between the QRS complexes. And if the T wave ends at or before this line, then the QT is normal. If it ends after, then that can be lethal. And we'll go over that further if we need to. But please know all of your intervals. And I have another video that I'm going to post that explains exactly what you're looking at when you look at this cardiac rhythm strip. Hope this helps. If you have any questions, let me know.